Welcome back. This will be our third lesson on properties of geometrical figures. This lesson will look at the actual formal proofs of finding whether a pair of triangles are actually congruent, right? Just a little review. In the last video, we looked at congruency test, right? We got 4 to find out whether a pair of triangles are congruent. We had SSS, SAS, AAS, and RHS. Okay, now we're going to look at the symbol for congruency because we will need to use it to find to make the final statement that these pairs of triangles are congruent. Now the symbol for congruency is 3 lines that are horizontal, right? If you want to just write it down, it is 3 horizontal lines. Hopefully this loads. There you go. So it's 3 horizontal lines, just like this. That's how we denote it's congruent. Okay, let's look at our example. We have AC and BD are straight lines that intersect at P. So they must make pass each other. That's what intersect means, such that AP equals to PD and BP equals to PC, right? Prove that triangle ABP is congruent, right, to triangle DCP. So just like the diagram, they have noted that angle AP is equal to, line AP is equal to PD, right? They denoted it by 1 hungry jack chip. Then BP, or the line BP and the line PC, is exactly the same length, right? Denoted by 2 hungry jack chips. Now, what I need to do now is prove that these 2 triangles are congruent. This is what we're going to do, right? We're going to use the stuff that we already know from the question. We know that AP equals to PD. That's what my first step will be, right? AP equal to PD. The reasoning for this is the word given. Whenever you use the reasoning for given in finding out if these triangles are congruent or not, given just basically means that the information was already given to us in the question, right? Simple as. Right, next one. Another thing that was given in the question was BP equal to PC. Again, my reasoning is given, right? It was given to us. Now, SS, right? The 2 pairs of sides have been given to us. Let's try and see. Okay. This angle here, angle CPD, right, should be exactly the same as angle BPA by that reasoning of vertically opposite angles, right? So what I'm going to write down is, right underneath, I'm going to write down angle BPA should equal to angle CPD. My reasoning is vertically opposite angles. Okay, and they are equal. So I'm going to add that up. Okay, I'm going to add that they are equal. Those 2 angles are equal. Therefore, right? Therefore, triangle ABP is actually congruent to triangle DCP because, right, this part here, this is a side. The next line is a side. And the lucky last line is an angle. So we use what type of test? We use SAS. Okay, and that's all I do. Okay, let's go to question B. All right, so I've proved in A that triangle ABP is congruent to triangle DCP by SAS, that test. My next part is prove that AB, so this line right here, is equal to DC. Right, this is much easier. Once we have already proven that those two triangles are congruent, no matter what angle, no matter what side, they must be equal, right? So this is the reason that you give when you have already proven that it's congruent, just like this, okay? You'll write down line AB is equal to line DC. My reasoning will be because they are matching sides in congruent triangles. Hopefully this will load. There we go. Congruent triangles. And they must be equal. If they're matching, they must be equal. Okay. Same thing for C, right? This angle right here, B, A, P, and C, D, P. They must be equal because we've already proven that it's congruent. Again, same thing. Angle BAP is equal to angle CDP. Because of B, we had matching sides. This one, my reasoning will be matching angles in congruent triangles. We'll let that load. And that they are equal. Okay, super easy. So I'll see you guys in the next one.